All right, welcome to the first key issue of the textbook. I know we've been doing some other things in class so far. We've been talking about short history of the world, been doing a few map things, but this is the specific information you need to know for our course as far as the AP exam goes, our class exam. This is the meat of the course. Everything else very helpful in understanding this information, but yeah, this just starts the meat of it. So you'll notice, we probably already talked about this in class, that the textbook's broken down into chapters and key issues. So you see on the screen is 1.1, so it's chapter 1, key issue 1, and most of the textbook chapters have 4 key issues. So you'll notice that I refer a lot to 1.1, 1.2, and so on. So just so you know, that is the actual chapter and key issue. Now, this is an important idea to have because you're going to have a key question with each one of them. So you guys see on this one, it's why is geography a science? So in essence, the entire key issue is trying to answer that one specific question. So that's what we're going to be doing here. Now, you'll notice on the PowerPoint slides we have a lot of pictures. I have links that we're going to talk about throughout the course, so I'll let those play on these recordings so you guys can watch them, and I'll kind of give you some information before, after, so on. And a lot of the same thing with pictures as well. I'll show you guys some pictures, tell you why they're significant, ask some critical thinking questions, try to think about those whenever you're looking at the slides and you're listening to the recordings, because then we'll talk about them when we go back through these in class. All right, so let's get rolling. First picture of the world, figure that was fitting, right? So about this geography stuff. A good, like, non-scientific definition of geography is the why of where. That's how I describe our class to everybody. So you look at where something is and you say, okay, why is it there? What has happened to that thing or that phenomenon as it's located there, and so on. But if you did want an academic definition, that's in that blue in the screen, the social scientific interpretation of people and places. So we look at places, we look at people, and we look at the impact on each other, actually. It's a good way to look at it. Now, one of our first types of maps here. We'll go through a bunch of types of maps, actually later on in this specific key issue. But look at this map at the bottom. It should look weird to you. Hopefully none of you are like, oh yeah, that's the world. It's not. Well, it is, but it's obviously shaped a little bit weird. So this is called a cartogram. Hopefully some of you were saying that even before you heard it. A cartogram is a map where the countries or whatever are reshaped according to a statistic of some sort. Now you're staring at this and I'm hoping there's some light bulbs going off, and some of you are thinking, oh, I know what that is. This current map is resized due to population. So that's why you see China and India are really big, then United States third, and so on. That's why if you look up top here where Russia is, and even Canada, so Russia here, Canada over here, they look little slivers of countries just because they're not that big population wise. Anyway, so yeah, it's called a cartogram. Now, next thing, globalization is one of the biggest keys in our class. We're going to talk about this over and over and over again, and kind of like half joking, half not. If you ever need an answer to a question in class, globalization can actually be your answer. It's a set of processes that are increasing interactions of people without regard to country borders. So look at it like this. Globalization is the figurative shrinking of the world. Think about a news event that happens. It happens now, you know about it instantaneously. It's kind of crazy when you think about it. Like if you have a terrorist attack around the world, or if you have someone win an award, it's instantly kind of like shot out so that people have access to that information thanks to social media, right? Instagram or whatever you people use most now, Snapchat. But globalization, just think about figurative shrinking in the world. Now this is a lot like what we call pop culture. So globalization is having everything everywhere as well. So you guys will see there's a couple pictures here. Subway on the bottom left in France. So there's a great example of globalization, something that's located all over the world. McDonald's up there in Eastern Asia too. And then Taylor Swift, she's taken over the world, right? But pop culture is a great way to look at globalization. Pop culture is a thing because of globalization. So, now, globalization has an opposite. So the opposite is local diversity. So this is continuing to do whatever you've done despite globalization. So think about this as local diversity is slapping globalization in the face, saying we're going to continue doing what we've always done in spite of globalization. So we'll have tons of examples this year, but this is like folk culture. So bottom left, you see some homes here. This is in Japan. You would not see those homes in Charleston. That's the example of folk culture. So on the flip side, we have something called Charleston style homes, and hopefully some of y'all know what I'm talking about. It's kind of like the narrow long homes. So that's another example of local diversity or folk culture. Now, bottom right is another good example. Food is a fantastic example, just like we were talking about McDonald's and Subway on the last slide. So this is in Turkey. So I'll talk about the places I've been a whole bunch. This is actually a specific picture I took in a place that I've been. But Turkey street food is different from street food in the United States. So what you're looking at in that picture is corn and also hazelnuts, grilled hazelnuts. Not something you'd see on the side of the road in New York or Charleston or anything like that. So pretty interesting. So think about globalization, local diversity, two opposites. So, back to geography, the word itself. It's coined by Eratosthenes. So, Eratosthenes is a Greek guy, and a good theme for this year is if you get any question ever about the origins of geography, always think about the Greeks. So, Eratosthenes, he coins the word itself. Geo means earth. Graphia means writing. So together it means earth writing. So that's legitimately what the word geography means. Eratosthenes, I didn't put it on the slide, but he also did something else really important. And I think Rubinstein talks about this in the book. He estimated the circumference of the earth till like really close. I don't know how he did that. Because remember now, he's BCE because he's a Greek. So he did this thousands of years ago. Pretty impressive. Without Google, I don't even know how I would do that now. Science, it's crazy. So, contemporary geography. Contemporary means modern. Hopefully, some of y'all knew that. So, current geographers now they ask two main questions. They ask where and they ask why. So, where are things and why are they there? So that's the two biggest questions, which goes back to one of the first things we talk about, which is the why of where. Now, two types of geography: physical geography, human geography. So physical is probably what most of you thought of before you took this class. Actually, it's probably what some of you still think our class is. That's mountains, rivers, stuff like that. That's some of what we talk about in here, but we're more talking about the human. So the human is how humans interact with the earth, how humans have impacted the earth, all those different things. So huge, 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 all kind of like encompassing phrase there. So human geography is like population, migration, culture, so language, food, religion, things like that, housing, politics, agriculture, economics, industry, urban planning. So in other words, like how a city's shaped, like where do you put roads, what do you have power plants, where there, it's things like that. So human is very all-encompassing, and that's mainly what we look at in our class. Okay, so physical and human, and we look at mostly human. Isn't that picture crazy? How'd they get the clouds like that? That's crazy. This is a once in a lifetime thing. I know it's Photoshop. Don't worry. Some of you are like, he's stupid. Yeah, it's Photoshopped. So, place is an important term. So we're going to go through a whole bunch of terms right here. So place is the first one. Place specific point on Earth distinguished by a particular characteristic. All right, so make sure you kind of understand. We always talk about, oh, what's this place like? It's really saying this one location on Earth, what is significant about it or what is unique about it. So that picture, some of you guys might know this. This is Ia village in on the island of Santorini in Greece. So really, really cool looking place, very unique. Next term, region. So a region is if you have a lot of places together, and then the collection of those are a region. So definitely area of Earth distinguished by different characteristics. So a lot of places together that are the same. Now that map you're looking at, we may have already done this in class. I can't remember because I always record these in the summer. So this is a world region map. So these are different regions, but you'll notice something that you might not have the same exact world region map in your mind, which we're going to talk about a term for that a little bit later. But those are world cultural regions you're looking at. So next term, scale. So scale we're going to go over a few times. Actually, here we're going to go over it a couple of times just in this one specific PowerPoint. But it's a relationship between what you're looking at and the actual Earth. So all right, look at this on the right side. This is confusing, okay? It has to do with math. Math is hard. So this top map is Atlanta. The one under it's Atlanta. The one under it's Atlanta. The one under it's Atlanta. Okay. So these are different scales though. So the one on the top is small scale. See how the whole chart lines up? The bottom is large scale. Now that's kind of opposite of what your brain thinks. The large and the small scale actually comes from the fraction right here. So think about it this way. Small scale map shows small detail. So see how this map of Atlanta is really the whole United States? Large scale map shows large detail. So this bottom one shows a zoomed in picture of it. Okay, so think about that. Think about that phrase. So small scale map that has small detail, large scale map, large detail. Cool. And again, we'll go over that multiple times. Don't worry. Some of you are like, oh, that's easy. But yeah, we'll review that. Now, next thing, connections. Connections are huge in our class. We want all of you to try to connect familiar ideas to unfamiliar situations. It's hard. It's a different type of thinking than what you've had to do, especially through middle school. It is very, 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 very difficult. So it's a relationship between objects, people. In our class, it's a relationship between two ideas. And think about this too. The more people you have in a place, the more stuff you have in a place, the more connections you're going to have in a place. So this picture right here is in the Grand Bazaar in Turkey. There's a lot of people in that one spot. Oh, oof, I don't like that. Too crowded, man. Made me nervous. Anyway, so connections, 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 connections. Now, maps. Okay, two purposes for maps. Before we get to those, funny map at the bottom, how Californians see America. Obviously, this is not accurate. Making fun of Californians a little bit, making fun of stereotypes a little bit. It is funny. So, but this is a specific type, so we're going to talk about the two purposes, and we'll see which one you guys think that fits in. So, as reference tools, so that's to find your like way around places, so things GPS or whatnot. And then as a communication tool, so to show distribution of human physical features. So this funny map of how Californians see America, I'm hoping most of you are looking at that and you're like, that fits under the communication tool category. Hopefully you guys weren't thinking reference tool. Maybe you were. I don't know, maybe you're looking for Vegas and you guys are going over here somewhere. I don't know. It's up to y'all. But that's a communication tool. All right. Next thing, so early maps. We're talking about the Greeks again. Early maps used for navigation. So it's really not so much like the last map we looked at. This was finding your way around. Aristotle, really important guy. All right, make sure you know him. He's one of the first people smart enough to say the Earth was not flat. Earth was round. But still, he knew that mapping was important on the round Earth, so that way we could find our way around the round Earth. Hopefully that's making some sense to y'all. He's also a tutor of a very famous person. Anyone know? I know I can't see you raising your hands or anything, but it's Alexander the Great. Aristotle was his tutor, which is pretty cool. All right, so scale again. So back to what we were talking about a little bit earlier. there's a few types of map scale. So there's a ratio or a fraction. So you can see on this one right here, so you're looking at United Arab Emirates, Dubai down here. See where it says 1 to 1 million? So that is a ratio or a fraction. So that shows you like 1 inch or whatever equals 1 million miles or whatever you're looking at. Okay. Next one's written. So see how it literally just says 1 centimeter on the map equals 10 kilometers on Earth? That's a written scale. And then the graphic. So if you look down here, this is a graphic scale. Now we'll actually talk about, there's a little bit of a deviation on what we're doing currently, but these are the Palm Islands in United Arab Emirates. Pretty cool that they made these. There's a funny kind of couple stories to this that we'll talk about later on. So. All right, projection. So projection is key. So think about this. So with projection, you have to take a round globe and then make it flat. So let's watch this little video real quick. And this will help kind of explain it.
Have you ever considered taking an orange and flattening its peel? Because the orange is spherical, it is impossible to flatten it without stretching or tearing the peel. Mapping Earth provides a similar challenge, turning the spherical surface of Earth into a flat map. In mapping, this flattening process is accomplished through a map projection. A map projection is a visual device that enables mapmakers to represent Earth's curved surface on a flat map. All map projections result in distortion of Earth's surface, affecting the apparent shape or size of an area, or changing the distance or direction from one place to another. For example, Greenland and Argentina are of similar size, but in this common map projection, Greenland appears larger. This is an example of distortion. The goal of this tutorial is to introduce you to different kinds of map projections, their properties, and their uses. First, we will look at the graticule.
That's good enough. You don't need to know that part. So the key there was when they were talking about distortion. So anytime you flatten something from the globe, something's going to be distorted. So they talked about Greenland, Argentina, how the size is a little different. So those are types of distortion. And these ABC, those are types of projections. So different projections have more distortion than others. Don't worry too much about the different types of projections. We'll talk about those later. Even when we get closer to the exam in May, which I know seems like some far away magical place, end of school, but I will get to projections more. So, a couple of things about distortion though. Shape, distance, relative size, and direction. Those are the things that are most distorted. Alright, so that hopefully those make some sense. We can talk about them in class if you guys have any questions on that. Now, topographic map. So now we're going to go types of maps. This one you're probably familiar with. I know over the years a lot of people said in middle school, I think maybe the Lang kids, you had to make these in science. So these show elevation. So you can see on the map over here, the closer the lines are together, the more steep things are. We will not look at topographic maps too much in class, but they might pop up somewhere in the exam. So hey, at least know what they are. Now the next one. Okay, this gets a little more difficult. So thematic maps. So thematic maps are broken down into multiple subcategories. So the first one is called a chloropleth map. Now chloropleth kind of sounds like chloroplast, right, from science. This expresses a theme or expresses an idea by using colors. So you look at this map on the right, all NFL players, home state rates. This map's a couple years old, but it's probably still relatively accurate. So without even having a key, you can see that Louisiana and Mississippi probably have a higher rate of NFL players that come from those states. So that's percentage wise. So that's easy, right? Chloropleth maps use colors. They don't all have to be the same color. It can be different colors. Okay, so chloropleth colors. Isoline maps. So they calculate data across a surface. The most common type you'll see in our class, and you'll be asked about on the exam, are going to be weather maps. So you can kind of see these in example weather maps. See how it kind of flows and changes. It ignores the U.S. state boundaries. So it just shows across a surface how data could be different. That's a good way to look at it. And so think about weather. So weather forecast, how the north, is going to be colder than the south 99.8% of the time. Okay. Now a dot density map is pretty easy. Uses dots to show density. hmm So this map, every dot represents 100,000 people. So that's a lot of people. Now, let's pause for a second. Now, take a look at this map. This tells you a lot about the world. So, if you're looking at it, there should be a couple different things that are sticking out to y'all. The first one, I'm thinking, is most people live near the coast. You guys notice that? I forget the exact stat. I should really look this up because I forget the exact number. But it's like 80% of the world lives within 90 miles of a major water source or something like that, counting rivers, lakes, oceans, seas, all those different things. So you notice here, definitely most people near the water. The places that people don't live are kind of harsh, and we'll talk about that a little bit later when we get to chapter 2. So these are like mountains and then ice up here. Down here in South America, that's the Amazon rainforest. So this Sahara Desert, actually there's another desert down here called the Kalahari, and then this is the Congo rainforest. This is the middle of nowhere. Kind of like the middle of Asia has deserts just kind of like spring throughout there. This is like the Middle East where deserts are, cold up in Russia, the outback in Australia. So they're not exactly like very conducive to people living. And you can definitely tell where the cities are on this map too. You can see that Europe's very densely populated with cities. See how it's almost just completely colored in with dots. So, and you can tell India, eastern part of China. So you can definitely see where people are living. Okay, all right, moving on. Still with maps. So still thematic. Flow line map. Now these make a lot of sense, right? This shows movement and shows direction using lines on a map. So here you'll see immigration into the U.S. It's an old map, '07. I should put a new one up there. But it's pretty simple to tell what they're trying to get across, right? It's just arrows, number of people flowing into different places in the U.S. And actually here where the arrows go don't technically mean a whole lot. But anyway. Now our cartogram, we talked about these, remember? At the very beginning of this discussion. So it shapes areas, I have a typo in there. Oops. So it shapes area and is purposely distorted. Now, this is not population, the cartogram right here. So hopefully some of you all are thinking, what is this? So this cartogram is shaped due to money. So it's a stat called gross domestic product, GDP. So that's why the United States is pretty big. And then China's pretty big too, but we're the largest. And then Europe looks like a slug of some sort. Now look at Africa. Can't even recognize it, right? Because most of their, especially Central Africa, see how they're poor countries? Kind of crazy. And that's why Japan has gotten big. Canada's hanging out there. Where's Russia? Is that Russia? I think so. Yeah, there's Russia right there, a little green blob. So it says GDP cartogram. Okay, all right, so those are our maps. Make sure you know those backwards and forwards and at least have a little bit of an example of each of them. Now, the U.S. Land Ordinance of 1785. So this is interesting. This has to deal a lot with maps, a lot with money, a lot with kind of everything. This is a good thing here for 1.1. So what happened was a long time ago, 1700s, 18th century. Hopefully you guys remember that. So people start moving out west in the United States. So they thought of themselves, the U.S. government, they said, okay, how are we going to control this? So it's not just a free-for-all and people are going to roll west, be like, this land's mine. So this is what they created, the land ordinance. Now, under this is something called the township and range system. So what they did is when they sold plots of land in the west, they sold them in little blocks. So you see how a township is 6 square miles on each side. So you could purchase a township. And how do they draw these? This the blue writing down here. They used principal meridians, and baselines, which are latitude and longitude lines, which I'm not too worried if you guys know a whole bunch about that. But so the example, remember, back in the day, this is kind of funny to us now, in the 1780s, Ohio was west. So go figure. So you guys see how they have this little chunk out right here in this little inset map? So this is what it looks like. So here's those 6x6 areas. And if you zoom into one of these, you can see, is that basic math, that you have 36 little blocks, little square mile blocks that you can purchase. All right, you guys see how that works? So, what do you think this did to the way the United States looks? So think about that for a second. Okay, what did the township and range system? How did that impact the way the U.S. looks? Hopefully, some of you are thinking it right now. You might even be talking to yourself. Um, but this, is what it did. So it made the western U.S. states very, very square. So this is obviously from a plane, or maybe not so obvious, but this is from a plane. Western U.S. I have no idea what state. Just took a picture from a plane, and you can see how there's square plots of land. Land Ordinance of 1785. Now, where's my map? I used to have a map. Man. Anyway, if you look at the western part of the U.S. on a map, it's very squared. All those U.S. states, Colorado, all those. So the reason is the land ordinance, 1785. All right. Now, okay, last thing for 1.1. Modern technology, GPS. You guys are pretty familiar with GPS, but uses satellites to determine the precise precision of something on Earth. So the satellites communicate with each other, which is pretty interesting. Um, so GPS used to really only be used by like geographers, scientists, stuff like that. But recently, it's actually become a really like affordable, cool thing for us. First thing you guys might be thinking about are like GPS maps, getting places on your phone in your car or something like that. But geotagging, see this down here? Geotagging is kind of newish. If you guys ever taken a phone, take a photo with your smartphone. I know iPhones do this. I'm pretty sure most of them do now. Instagram does this. Facebook does this. Not that you guys use Facebook anymore. Uh, but you ever taken a picture and it'll actually pinpoint your location, and you can look at a map and say, "Oh, look, all of my pictures in my album. Here's where it was taken. Whether it's Mount Pleasant, or whether it's somewhere in Europe, or somewhere in Australia, or somewhere in Africa, or something like that." So that's geotagging. So geotagging is using GPS signals to see exactly where something is. Um, I don't know if any of you have even noticed this, but like my phone will do this because none of you drive yet. But if you park somewhere, sometimes Google Maps will say, location of car stored, which it's kind of weird, right? But it actually like stores your location, so that way if you forget where you park, boom, you can go back and find it later on. Okay, so that's geotagging. That's used by GPS too. It's pretty cool. All right, so geographic information science, GI science. So that's a big category. Underneath that is other categories. So geographic information science, under it has geographic information systems, and then it has remote sensing. So geographic information systems, that's like making layers of maps here. You guys see these? So and I'm going to show you Google Maps in a second, but it's adding layers on to places. So you can add, if you type in like grocery stores, it actually adds a layer and show you where grocery stores are on a map. And remote sensing, a similar idea. What that does is that's like a satellite or a plane taking a picture, so they can actually sense what's going on the ground level. And then obviously we have access to that as like the public of the world. But that's where if you're looking for, I think of a good example here. If you're trying, if you're a farmer, not that any of you are farmers, and you're trying to see soil types, you can use remote sensing to see kind of like heat of the soil, like the makeup of it. So you just take pictures of it. So it's pretty cool. All right, so let me show you guys how GIS works. GIS was another thing like GPS that was only really available for like really high-end scientists and whatnot. But now anyone can pretty much use it. So you see here, here's Mount Pleasant on Google Maps. So if we go over here. So see where it says satellite traffic and all that? So just one GIS thing that's pretty easy. If you click on traffic, they're going to have an overlay and show you where traffic is or how traffic is flowing. So see how currently, right now in Mount Pleasant, everything looks pretty good. So everything's pretty green except for there's a little traffic right here down by the bridge. But that, remember that just added a layer on. So let's say you wanted to go look at restaurants. So boom, another layer. See how I just added another layer? And so that is GIS. So ooh, Mo's, love Mo's. So anyway, so that is all part of geographic information systems. Okay, you guys got that? All right. So this is something Miss McGee hates this part. I lied. I said the other thing was the last thing. Here's the last thing. So latitude and longitude lines. So we're going to explain this, and then we're actually going to do a little activity in class with this after hopefully most of you have seen this recording. So latitude lines are also called parallels. Longitude lines are also called meridians. Now, we're going to learn how to tell time. Now, we're going to review this in class, like I said, but let me give you guys a quick rundown of how this works. So this is going to be real quick. This is very confusing looking, right? Oof. Now, in your atlas, we're going to look at a map that's way, 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 way easier to read than this. But some of you might know this. This right here is called the Greenwich Meridian. It runs through Greenwich, England. I was just in England this summer, and actually I should have stopped by Greenwich. So this is what we think of as hour zero. It came up with time zones originally because they wanted to get like trains and planes and boats. Well, not planes yet. Mainly trains and boats all on the same schedule. Because if you're leaving at like noon somewhere, like what time is that? You know, like 500 miles away. So that's why they came up with time zones, just so we can kind of with global commerce and with globalization, so we could kind of like communicate correctly. Now, here's how these work. Okay. So again, this is the Greenwich Meridian. Now, every 15 degrees longitude, remember longitude, they run up and down, they run north and south. So every 15 degrees is another time zone. Every 15 degrees is 1 hour. So, do you see how this green right here and then this blue, those are two different time zones. So, see how on the Greenwich Meridian, I know it's kind of hard for you all to see, it's 1:59 a.m. So 1:59 a.m. right there, if you bump over, then all of a sudden that's going to change time. So if you go to the right side over here, that's going to add time. If you go to the left side, it's going to subtract time. So east add, west subtract. Now, kind of a weird thing is when you hit the other side of the world. So you see where it says International Dateline over here on the left where the cursor is? When you cross that line, you move ahead or behind 24 hours instantaneously. So I'll show you a couple things in class on how that works. But yeah, ahead or behind 24 hours. So automatically, right? You just go there. So a couple years ago, I went to Australia, New Zealand, and Fiji just for a trip. And I lived July 9th twice because when we flew back from Fiji, we crossed the international date line and we moved backwards. So I had two July 9ths in my life, which is kind of weird to think about, right? So that's very basic. So Greenwich, that's kind of like where hour zero is. If you move east or west 15 degrees, each 15 degrees is 1 hour. And then the international date line itself, that's ahead or behind 24 hours. Okay? All right. So that is it for 1.1. In class, and we might be doing it right after this, right after you watch it, we're going to talk about latitude and longitude, okay, a little bit more, but that is it for 1.1. Hopefully it's a lot of information, right? Think about it, every key issue is going to be like that. So, all right, time for y'all to move on to 1.2 or take your quiz on 1.1. All right. Thanks.